Hello and welcome back to our distance learning classroom. Today is day 7 for distance learning. So it is Thursday, April 23rd that you're watching this video. So I know we didn't use the classroom last class, so you have your joke of the week up now. So just a quick refresher on the topic we were looking at. We were discussing similar triangles and specifically their scale factor to find some missing values. We're going to continue that discussion today. And so if you need to look up other videos in case this wasn't clear for you or you need some more examples to look at, we're going to use similar triangles to help us find missing values. And so we'll use my artwork in a second. So two main takeaways about similar triangles. The corresponding angles in similar triangles are congruent, right? We talked about one of the ways to tell if two triangles are similar is if at least two of the angles, corresponding angles are congruent. That means the third is also. So AA or AAA was one of the ways that we can do that. The second big takeaway about similar triangles is that corresponding sides are proportional. So unlike congruent triangles where they're exactly the same, here they're going to be proportional. So it can be even bigger or smaller depending on if it was an enlargement or reduction. And then lastly, the way we tell is using that scale factor. And so that is a ratio. We're going to use the new measurement to the old measurement as our ratio. So those are the two main takeaways about similar triangles, specifically the scale factor at the very end. And so something that we have done is look at examples such as this. So here I'm giving you two triangles and I can tell that the blue and the green triangles are similar based on their angles. So if I look at this angle right here, which corresponds, so angle A and angle X are corresponding because they're in the exact same position, and I know that they are congruent because of that little dash. Angle B and angle X are also corresponding angles and they're congruent, so that's at least two angles congruent, which means the third has to also be congruent to each other. So these two triangles are similar because of the angles that were given, but the very big thing that we need to talk about is its scale factor in order to find a missing value. So here we have the measurements of 3, 4, and 5 units, and here we have 9, 12, and blank. So we are going to look for what that blank is right now. And we're going to use our scale factor to help us figure this out. So remember when we're talking about our ratios, we want to use the new measurement compared to the old one. But we have to use corresponding sides to make that work. So if angle A and angle X are corresponding and angle B and angle Y are corresponding, that means that side AB corresponds with side XY. So I can set up that ratio. And we're going to use our new to old, just like we did last class. So our new measurement is 9 of that leg. Our old measurement is 3. So our ratio would be 9/3. I can use that to make a proportion. So that is going to be equal to our missing piece. Remember, they're the same. So the same thing would be true about 12/4. We'll prove that in a second. But my new value is what I don't know. So I can call that X. I'm not sure what that value is, but I do know that the side that corresponds with YZ would be BC because of its position. And that has a value of 5. So what I've done so far is just set up a proportion. And just like we did last class, we can use our cross multiplication to help solve this proportion. So 9 times 5 is 45, and X times 3 would be 3X. And when I divide both sides by 3, I notice that X would be equal to 15. So this mystery number would be 15 because these have to be proportional, all three sides, all three corresponding sides. So the same thing would be true if I use 12 and 4. Because if I look at this relationship, 9 divided by 3 is 3. 12 divided by 4 is 3. 15 divided by 5 is 3. So our scale factor here would be 3. So I know that these are proportional using the scale factor of 3. So that was a very quick refresher of an example that you should have looked at in your Google form. But now we have this artwork, and I know you know how great I am at art. So we are actually going to use our knowledge of similar triangles to figure out the height of this tree. Now I'm going to give you some things. I'm going to tell you that this little guy right here, he's going to be 5 feet tall. So I know that he is 5 feet tall. I'm also going to give you a nice point right here. I'm going to say this is going to be our starting value, and our little guy is going to be 8 feet away from that starting point. So again, I'm just giving you some information. And I know his height is 5 feet and his distance is 8 feet. But I know also that the tree is going to be 24 feet away from that little star. So using this information, I want you to figure out the height of the tree. Do you think you can? If you notice, I'm starting to see that this shape right here is making a triangle. Figure out how tall he is. Now I don't know that measurement, but I do know this leg is 8 feet and this leg right here is 5 feet, and that would make a right triangle based on what we know about how he's standing. But if I continue that all the way to our tree, I have just created a triangle. So I know that these two triangles have to be similar. These two triangles are similar to each other because all three angles are going to be exactly the same. This angle is the same, right? It's the same in our smaller triangle and in our bigger triangle. We know this made a right angle based on how he's standing. This is a right angle, and if I know that two angles are congruent, then that third angle, even though we don't know what the value is, has to also be congruent. So what we have just drawn is two similar triangles to help us figure out the height of the tree. What we know about the first triangle is that the height of the triangle, or this leg right here, is 5 feet, and the distance from that star, that little point over here, is going to be 8 feet. I also know that the tree is 24 feet away. However, what I'm looking for, what I don't know, would be the height of that tree. So we are going to use proportions to help us solve for the height of the tree. We're going to use the ratio new to old. So we're going to pretend our bigger triangles are new. And so what I do know about our new triangle is that the length down here is 24 feet. And the old length of our smaller triangle would be 8 feet. So right now I know that 24 and 8 are corresponding sides. And that is going to be equal to what I don't know, which is the height of the tree, over the height of our guy. From there, we can use cross multiplication. 8 times 4, 24 times 5. I'm going to run out of room here, so I'm going to write it over here. So 8 times x would be 8x is equal to 24 times 5, which is 120. One step equation, divide both sides by 8. And x is going to be equal to 8 goes into 12 one time with 4 left over, and 8 goes into 40 5 times. So I now know that x is going to be equal to 15. But it's important to use the unit that was given. If this was in feet and that was in feet, then this is also in feet. So we just figured out that the height of our tree is 15 feet. So that's what you're going to be doing on this quizzes. You're going to be using it, I believe every single picture is given to you already, but using your knowledge of similar triangles and proportions, you're going to be solving for a missing value. So we're going to try this quizzes out. I know we did a Google form on Tuesday. We did this quizzes today. I think I'm going to go back to a Google form just so that you know what's coming up on Monday, because it's going to be a new topic. So it's kind of a review from our last lesson. All right, stay safe, everybody. I miss you. I really do hope to see you guys soon.